Hello and welcome back to Higher Maths Differentiation. This time we're going to be looking at increasing and decreasing curves. So let's have a quick look at a curve first of all. So here we have what looks like a cubic curve. So a cubic curve generally starts from down here, positive gradient, flattens out, negative gradient, flattens out again, and a positive gradient at the end. So essentially it's coming up, flattening out, going down, flattening out, and going back up. So in this section of the curve is strictly increasing. What does that mean? It means it's got a positive gradient, or in other words, it's going up. At this point here, the gradient's 0, which isn't marked on. We'll actually look at that in the next lesson. But between this point and this point, the curve is said to be strictly decreasing. In other words, the gradient is less than 0, so it has a negative gradient, or in other words, the curve is going down. And then the gradient 0 again, and then after that, it is strictly increasing, or in other words, it has a positive gradient, dy dx is greater than 0, or in other words, it's going up again. So a curve is said to be strictly increasing or going up when dy dx is greater than 0, positive gradient. A curve is said to be strictly decreasing when dy dx is less than 0, or it has a negative gradient. Okay, so let's just use that. So a curve has this equation: determine whether the curve is increasing or decreasing at the point x equals 10. So let's put it into a format we can differentiate first of all. So root x is x to the half, but we need to bring that up and make it a negative power before differentiating. Power to the front, reduce the power by 1. Negative 1/2 multiplied by 2 is negative 1. Reduce the power by 1 would be negative 3 over 2. Negative 1/2 minus 1 whole is negative 1/2 minus 2 halves, which is negative 3 halves. So we've differentiated. So I'm going to have to substitute in. So I'm just going to rewrite this as 1 over the square root of x cubed. So remember, negative power brings it down to the denominator. Top number is the power, bottom number is the root, so it's a square root of x cubed. So the dy dx, the gradient when x equals 10, will be just substituting in 10. Now the square root of 10 cubed is not an exact value that we're meant to be aware of, so I'm just going to evaluate that in a calculator. So it turns out to be 79.97. So when x is 10, the gradient is positive because the gradient is 79.97. So the curve is increasing. We're asked if the curve is increasing or decreasing, so we've said the curve is increasing at x equals 10 as the gradient is positive. Question number 2, show that this curve is never decreasing. Right, very specific question here. If we want to show something is never decreasing, we need to show that it's always either greater than or equal to 0. So we need to show that this is never negative. So find dy dx, so differentiating that's a reasonably straightforward one, which is always nice. That's x squared plus 2x plus 1. Now, just looking at that on its own, we don't know if that's always going to be positive or not. But for this particular type of question, we're asked to show if something's either never increasing or decreasing in this question, we'll need to show that that is bracket squared, possibly bracket squared plus something. Okay, so factorizing this, we get x plus 1, x plus 1. So dy dx is x plus 1 all squared. Now this can never ever be negative. Even if x is negative, say x was negative 5, we'll get negative 5 plus 1, which is negative 4. Squared is positive 16. So this curve is never decreasing as x plus 1 all squared is greater than or equal to 0 for all values of x, meaning the gradient is never negative. Again, the important part of that question, can this ever be negative? Find me one value of x for which this is negative. Okay, we can't do that. So the smallest this can ever be would be 0 squared, which is 0. For any other value of x, it's going to give a positive number. So dy dx is always either 0 or more, which means the gradient is either 0 or positive. Therefore, the gradient is never negative, so the curve is never decreasing.